All right, let's see different examples of mixed derivative. This is part 3. So the first one, let's see an example. Find f derivative at x for f of x is 12x multiplied by e to the x. This one is a product rule. So you can see this is the first function, this is the second one. Now let me, f at x is 12x and the second function is e to the x. The derivative of this one is 12. The derivative of this one is e to the x. So f derivative at x is 12 multiplies e to the x plus e to the x multiplies 12x. So you can write here e to the x is common, the common factor. So you can write 12 plus 12x. This is possible. Or you can write also this one as 12 e to the x 1 plus x, also possible. Or some of you may write this one as, if you write 12 x e to the x plus 12 e to the x also is okay. So the three versions are possible answer. Let's see an example 2. Example 2, let's say find f derivative at x for f of x is x squared e to the x. Now you can see the first function is x squared and the second function is e to the x, and the derivative of the first one is 2x. The derivative of the second one is e to the x. Multiply this. F derivative at x is 2x multiplies e to the x plus the second one is x squared multiplies e to the x. And this is okay. Or you can write this one also e to the x, which is x squared plus 2x. This is also another version because I just factored out. Or you can write also this one, another version, x e to the x plus 2. This is also a possible answer. All right. Example 3. Example 3. Let's see f of x is, let's say, e to the x divided by 7x squared plus 4. If this one, find f derivative at x. All right, the top function is e to the x, the derivative is e to the x, right? The bottom function is 7x squared plus 4, and the derivative is 14x, and we use the quotient rule, don't forget. So the derivative of this one is, remember, e to the x multiplies 7x squared plus 4 minus 14x multiplies e to the x over the bottom one is 7x squared plus 4 the whole square. Now when you look at the top one, you have to simplify. E to the x is factor out 7x squared plus 4 minus 14x, divided by 7x squared plus 4 the whole square. So this is a possible answer. Or the polynomial in descending order, you can write e to the x 7x squared minus 14x plus 4 over 7x squared plus 4 the whole square. This is the derivative of the function, which is I just write in descending order of the polynomial on the top by factoring e to the x. This is example 4 or 5. Okay, example 3. Let's example 4. Find f derivative at x for f of x. Let's see, 9 plus 8x minus 3x squared times e to the x. This is a product rule. Now you can see this is the first, this is the second. The first function is 9 plus 8x minus 3x squared. And the second function is e to the x. The derivative of the first one is 8 minus 6x. The derivative of the second one is e to the x. Remember product rule. F derivative at x is 8 minus 6x multiplies e to the x. And the second one, e to the x multiplies 9 plus 8x minus 3x squared. E to the x is common, so I can factor out e to the x, 8 minus 6x plus 9 plus 8x minus 3x squared, right? When you just factor out the e to the x. So e to the x, now look at the, this one and this one, and this one and this one, so 17 plus 2x minus 3x squared. This is the derivative of the function. All right, let me add one more example 4. I think this is 5. Find f derivative at t for f at t is 5 plus e to the t ln of t, right? Now this is product rule. Look at f as a function of t is 5 plus e to the t, and the second function as a function of t ln of t. So we can use the product rule. What is the derivative of this one? It is just e to the t. The derivative of this one is ln of t is 1 over t. Right, so product rule. So f derivative at t, this multiplies this one, this multiplies this one, and plus, right? So e to the t ln of t plus 1 over t multiplies 5 plus e to the t. Now you can distribute this one, e to the t ln of t plus 5 over t plus e to the t. That is one possible answer, over this is t. This is okay. Or if you just want to use the same denominator, you can write this one 1t over t, right? So you can write et, right? Right? Et, there is t ln of t plus 5 plus e raised to t over everything is t. This is also another version of writing the derivative of the function, or this one. So I recommend you to practice more in order to easily get the derivative of a given mixed functions, the derivative of mixed derivatives. So the functions can be given as a product, quotient, and chain rule. So those derivatives are known as mixed derivatives.